What makes the sum of cointerior angles constant on either side of the transversal? Greetings and welcome to the new math channel. In the last video, we defined angles and right angles. Here's a quick review. An angle is the ratio of the circle's arc length to its radius. A right angle is formed when the circle diameters intersect each other so that all four angles are equal. Perpendicular lines are diameters that form right angles. In this video, we will systematically derive the fifth requirement of Euclid's elements, which states, the sum of cointerior angles is constant on either side of the transversal. Let's review transversal and parallel lines along with cointerior angles and alternate angles from the last video. A transversal line is defined as a line that intersects two different lines. The lines being intersected may themselves intersect each other without respect to the transversal. All the lines shown in this figure are transversal lines. Parallel lines are defined as chords or lines that are subtended on equal arcs between the chord and diameter and are said to be parallel to the diameter. In the figure shown, the green lines are parallel and the blue arcs are equal. A cointerior angle is defined as an angle that lies between two different lines on the same side of the transversal. An alternate angle is defined as an angle that lies between the parallel lines and is equal to the cointerior angle located at the other parallel line on the opposite side of the transversal. Now, let's go through the fifth requirement. Theorem. The sum of interior angles on either side of the transversal is constant. First, let us prove that the sum of two cointerior angles are right angles. Given that only one transversal is perpendicular to the other diameter, it follows that a parallel chord will also intersect the transversal at right angles. Therefore, the sum of angles formed where a transversal cuts two parallel lines is two right angles. Because the parallel line is straight and by symmetry, the alternate angles are equal. Transversals are also diameters. The lines are parallel provided the sum of two cointerior angles is equal to two right angles. Proof. If we take any other diameter as a transversal, one that is not perpendicular to the chord or remaining diameter, when we see that the alternate angles are equal by symmetry about the transversal. The sum of two cointerior angles is always two right angles, regardless of how the transversal cuts the parallel lines. Next, we will define a triangle and establish a theorem regarding the sum of its angles. A triangle in a plane is defined as the shortest distance joining 3 points. Two of these points lie on one parallel line and one point on the remaining parallel line. Next, let's define what supplementary angles are. Supplementary angles are angles with the same vertex such that their sum is two right angles. We will begin the proof that the sum of the angles in a triangle are two right angles using alternate angles and the property known as transitivity of equality. The property of transitivity of equality states that if x equals y and y equals z, then x equals z. Proof. Here is a triangle with points A, B, and C. Let the lone angle with vertex C on the parallel line be denoted by Z, and the other two angles with vertices A and B, respectively, on the remaining parallel line be denoted by X and Y. Then AC and BC are transversals so that the alternate angles that are supplementary to Z are equal to the corresponding alternate angles and on the other parallel line, that is, the angles are supplementary to X and Y. Since the triangle consists of all the angles that are supplementary on the parallel line where the lone line is located, it follows that their sum must be two right angles. As one can see, it does not matter if the lines are parallel or not. It also does not matter how the transversal cuts the lines. We can summarize the fifth requirement as follows. Number 1. If the lines are parallel, then we are done. We already know that the cointerior angles have a sum of two right angles. Number 2. If the lines are not parallel, then we know that a triangle is formed on the side of the transversal where the non-parallel lines meet. Given that the angle where the lines meet does not change, it follows that the sum of the remaining angles is constant on either side of the transversal. The fifth requirement of Euclid's elements has been derived. In the next video, the concept of number will be derived.